Hi everyone, so today we're going to talk about continuity and discontinuity, and we sprinkled in a little bit of end behavior as well, so let's go ahead and dive right in. The graph of a continuous function has no holes, breaks, or gaps, so you can really imagine this as you being able to trace the graph of a continuous function without ever lifting your pencil or your stylus. So it would look something like this. Now, to better understand continuity of functions, it's actually going to help us to understand the different kinds of discontinuities that can occur. So the first one is called an infinite discontinuity. So it happens at a specific x value, and the function value either increases or decreases indefinitely as x approaches that particular value from the left and from the right. So you can really think about this as having an asymptote there. That's the easiest thing for you to sort of imagine. Now, the second discontinuity is a jump discontinuity, and it happens at a particular value when the function approaches that value, but they have two different y values. So you can almost imagine it as starting at one part of your function, and then you got to lift up your pencil to get to the other value as it continues. Now, these are both called non-removable discontinuities. Now, the third discontinuity that you can think about is called a removable discontinuity. And this is where your function is continuous everywhere else except for a hole. Now, it is a hole at a specific value. Now, this is a removable discontinuity, and you can almost think about it being a hole that can be filled. That's probably the easiest way for you to remember this. Okay, so here we have two graphs, so let's determine what these discontinuities are and the value in which they occur. So the first graph we have looks like we have a jump discontinuity right when your x value is -5. Now, why is it a jump? I start from one sort of piece of my function. I got to move my pencil to reach the other sort of triangle. So this is a jump discontinuity. So I had to move from one piece to the other by jumping. And the second discontinuity looks like it happens right where x is -1. And again, pretty similar to the red piece, looks like this is also a jump discontinuity. I had to kind of start at that triangle piece, and I had to jump to get to another value and then start following down my function. Now, in the second one, it looks like right here when x is -4. Now, it looks like we have an asymptote there. So remember, you have an infinite discontinuity if you've got an asymptote there. Now, if we look at another discontinuity, as I continue going, I meet a hole, right? I meet a hole where x is -1. I meet a hole, and that is a removable discontinuity. And last but not least, it looks like we have right where x is 2, we have a jump discontinuity. Continuing my function, I got to get from one value, jump to another value where it would continue on. All right, so let's talk about end behavior. Now, the end behavior is where you're looking at a graph, and the behavior of the graph is when x is approaching either positive or negative infinity, we want to know what's happening to that function. So what is it doing? Where is it approaching? Is it a specific value or is it infinity? Now, in the graph on the left, you're going to see a couple things. So when x approaches negative infinity, so that means I'm looking on the left-hand side of my graph. Now, when I look at the left-hand side of my graph, what is my function doing? My function looks like it's sort of at a specific value. That y value doesn't get any bigger, doesn't change, and it actually approaches 1. And as x approaches positive infinity, now my positive infinities are to the right-hand side of my graph. So again, what is my function doing? What is the behavior? It looks like it continues and it points towards that value of 1. Okay, also looks like as x approaches negative infinity, again, the left side of my graph, well, again, my function looks like it's approaching that y value of 1. And as x approaches positive infinities are to the right-hand side of my graph. So what is it doing? It looks like it's pointing up towards the positive y's or positive infinities. Okay, in this graph, you got a lot of stuff going on. So we're going to state all the discontinuities and state the end behavior. So let's kind of bring everything we learned into one problem. So let's start with this x value right at -6. So when x is -6, we actually have a jump. We have a jump discontinuity. Okay, now let's continue on my graph. What do I see? I see a hole. So when that x value is -3, I see a removable discontinuity. As I keep on going with my function, I see right here, I see another hole. So when my x value is -1, I have again a removable discontinuity. And let's keep going. I go. Ooh, I hit an asymptote. So think about at that asymptote, you have an infinite discontinuity. And that happens where my x value is +3. And keep on going with your function. You should notice that you hit another asymptote. So when x is 8, again, you have another infinite discontinuity. All right, so we did all the discontinuities. Now for end behavior. So look, when x approaches -infinity, you are looking at the right-hand side of my graph. So where does my function point? It points towards the negative infinities or negative y's. And as x approaches positive infinity, I'm looking at the right-hand side of my graph. So what is my function doing? It is pointing and it approaches that value of 0. Now, I hope you found this video helpful. Don't forget to like and subscribe if you want to know about more videos in the future. Thanks for watching and have a great day.